friends, in this lecture, we will start the new chapter number 3, convection heat transfer. Thermal convection. Thermal convection occurs when a temperature difference exists between solid surface and a fluid flowing past it. Thermal convection છે એ સોલિડ બાઉન્ડ્રી એટલે કે સોલિડ સરફેસ અને તેમાં સરફેસ પાસેથી પસાર થતું ફ્લો થતું ફ્લુઇડ એમની વચ્ચેના ટેમ્પરેચર ડિફરન્સને લીધે રચાય છે. Convection is essentially a process of energy transfer affected by circulation or mixing of a fluid medium which may be gas, liquid or powdery substance. અહીંયા જે પણ પ્રોસેસમાં ફ્લુઇડ હોય છે એ ફ્લુઇડ મીડિયમ ગેસ હોય, લિક્વિડ હોય કે પાવડરી સબસ્ટન્સ પણ હોઈ શકે છે. એના સર્ક્યુલેશનની પ્રોસેસના લીધે અહીંયા થર્મલ કન્વેક્શન થાય છે. તો ટ્રાન્સપોર્ટ ઓફ હીટ એનર્જી ડ્યુરિંગ કન્વેક્શન ઇઝ ડાયરેક્ટલી લિંક્ડ વિથ ધ ટ્રાન્સફર ઓફ મીડિયમ ઇટસેલ્ફ. તો કન્વેક્શનમાં જે પણ હીટ ટ્રાન્સફર થાય છે ડાયરેક્ટલી મીડિયમ દ્વારા થાય છે. As such as a convection presents a combination of problem conduction, fluid flow and mixing. Convection problem છે એક conduction, fluid flow અને મિક્સિંગનું કોમ્બિનેશન છે. કન્વેક્શનના બે ટાઈપ છે, ફ્રી કન્વેક્શન એન્ડ ફોર્સ કન્વેક્શન. સર્ક્યુલેશન ઓફ બલ્ક ફ્લુઇડ મોશન ઇઝ caused by changing in fluid density resulting from temperature gradients between a solid surface and the main mass of a fluid. હવે જે પણ જે સર્ક્યુલેશન થાય છે ફ્લુઇડનું એ જો ડેન્સિટી ડિફરન્સના લીધે થતું હોય, ટેમ્પરેચર ગ્રેડિયન્ટ રચાવાને લીધે, તો એને ફ્રી કન્વેક્શન કહેવામાં આવે છે. The stagnant layer of a fluid in the immediate vicinity of a hot body gets thermal energy by conduction. The energy in the forced convection flow of a fluid is caused by pump, fan or by atmospheric winds. હવે ફ્લુઇડનો જે ફ્લો છે એ જો પંપ દ્વારા, ફેન દ્વારા કે એટમોસ્ફેરિક વાઇન્ડ દ્વારા હોય તો એ થશે ફોર્સ કન્વેક્શન. This mechanical device provides definite circuit for circulating currents and the speed up the heat transfer rate. Newton's law of cooling. Newton's law of cooling the rate equation for convective heat transfer between surface and the adjacent fluid is prescribed by Q is equal to HA in bracket Ts minus Tf. Q is the convective heat flow rate. A area exposed to the heat transfer. Ts and Tf are the surface and the fluid temperature respectively. The heat transfer coefficient H depends upon the thermodynamic and the transport properties, specific heat, thermal conductivity of fluid, density, viscosity, the geometry of a surface and the nature of a fluid flow and the prevailing thermal condition. Dimensionless number, Reynolds number, ratio of inertia force to viscous force. Re is equal to inertia force to viscous force. Equation rho v square L square divided by mu VL is equal to rho VL divided by mu. Reynolds number is an indicator of the relative importance of inertia and viscous effects in a fluid motion. At a low Reynolds number, viscous effects denominate and the fluid motion is laminar. વિસ્કસ નંબર જો લો હોય તો ફ્લો છે એ લેમિનાર છે, તો ઇનર્શિયા ફોર્સ છે એ ઓછો હોય ને વિસ્કસ ફોર્સ છે વધુ છે, એટલે ફ્લો હોય એ લેમિનાર છે. એટ હાઈ રેનોલ્ડ્સ નંબર ઇનર્શિયલ ઇફેક્ટ્સ ધ લીડ ટુ ટર્બ્યુલન્ટ ફ્લો ઇઝ ટર્બ્યુલન્ટ લેવલ ડિનોમિનેટેડ મોમેન્ટમ એનર્જી ફ્લો. હવે જો રેનોલ્ડ્સ નંબર હાઈ હશે તો એ ટર્બ્યુલન્ટ ફ્લો થશે. રેનોલ્ડ્સ નંબર કોન્સ્ટિટ્યુટ ઇમ્પોર્ટન્ટ ક્રાઇટેરિયન ઓફ કાઇનેમેટિક એન્ડ ડાયનેમેટિક સિમિલારિટી In a forced convection heat transfer, velocity within the given field would be similar magnitude, direction, and turbulent pattern when their Reynolds number are same. Next number, Prandtl number. It is the indicative relative ability of fluid to diffuse the momentum and inertial energy by molecular momentum. Prandtl number PR is equal to mu Cp by K. Mu is equal to rho mu Cp by K. Mu is equal to K by rho C. Prandtl number is equal to kinematic viscosity divided by thermal diffusivity. And this is the PR is the ratio of kinematic viscosity to thermal diffusivity of a fluid. Grashof number indicates the relative strength of a buoyant to viscous force. And this is the buoyant force and this is the viscous force. JR is equal to L square rho square L cube rho square Bg delta T divided by mu square. Then after this equation convert into rho L cube Bg delta T into rho V square L square divided by mu V L square. Buoyant force inertia force divided by viscous force square. Ratio to represent ratio of product of buoyant force and inertia force to square of a viscous force. Nusselt number relation between the convective film coefficient H, thermal conductivity of K, and the significant length L, physical steam. Nu is equal to HL by K. Energy balance at a surface of a heated plate stimulated the energy transfer by conduction must equal the convective heat transfer into the fluid flowing past. So Nusselt number is equal to HL by K. Q is equal to minus Ka del T by del Y HA is equal to HA Ts minus T infinite. H equal to minus K. બંનેની કમ્પેરિઝન કરવાથી આપણને મળશે H is equal to minus K del T by del Y divided by Ts minus T infinite. તો અહીંયા આપણે L અને K L divided by K નો ગુણાકાર કરીએ તો આપણને મળે HL by K is equal to minus del T by del Y Ts minus T infinite divided by L. This Nusselt number may be interpreted as a ratio of temperature gradient. Ratio of temperature gradient at a surface to overall reference temperature gradient. Nusselt number is a convective measure of a convective heat transfer coefficient. For a given value of Nusselt number, convective heat transfer coefficient is directly proportional to thermal conductivity of a fluid and inversely proportional to the significant length parameter. Staten number ratio of heat transfer coefficient to flow of heat per unit temperature rise due to velocity of a fluid. Staten number is equal to H divided by rho VCP. હવે આ ઇક્વેશનમાં H અહીંયા L divided by K નો ગુણાકાર થશે. અહીંયા rho V L divided by K divided by mu થશે. અહીંયા ઇન્ટિગ્રેશનમાં mu આવશે. અહીંયા CP mu CP divided by K એટલે અહીંયા સ્ટેટન નંબર ઇઝ ઇક્વલ ટુ બનશે Nusselt number divided by Reynolds number into Prandtl number. And the Staten number is equal to ratio of Nusselt number to the product of Reynolds number and the Prandtl number. Peclet number it is the ratio of heat flow rate by convection to flow rate by conduction under a unit temperature gradient and through thickness. Q convection mCp. M is equal to rho AV into Cp. Conduction Q conduction is equal to Ka delta T divided by L is equal to Ka divided by L. Peclet number is equal to Q convection divided by Q conduction rho AV into Cp divided by Ka divided by L. Rho Cp divided by K LV LV divided by alpha. Peclet number is equal to rho Cp divided by K LV rho LV mu into mu Cp by K this is the product of Reynolds number and Prandtl number. Prandtl number is the function of a Reynolds number and Prandtl number. This is the Gates number, represents the ratio of heat capacity of fluid flowing through the pipe per unit length to the conductivity of pipe material. Gates number is equal to mcp divided by L divided by K, mcp divided by Lk, rho av into cp divided by Lk, rho to area pi by 4 d square into v into cp divided by Lk, pi by 4 rho v d divided by mu, rho mu cp divided by K d by L, pi by 4 Reynolds number into Prandtl number to d divided by L. Answer Gates number is equal to mcp divided by Lk. M is equal to rho v a v into cp L divided by K. A v this is the mu cp by K is equal to thermal diffusion alpha by L, pi by 4 d square v alpha L, vd alpha pi d divided by 4 L. Gates number is equal to Prandtl number into bracket of pi d by 4 L.